Well, check this out. It is very rare to get hail of this size in southern Wisconsin. This was from April the 18th of 2025 in Evansville. That is northwest of Janesville in Rock County, and this is hail to the size of tennis balls. Again, very rare to see that here in southern Wisconsin. How does hail form, and how does hail this big form? Well, let's talk about it here. First of all, let's take a look at the hail sizes here, as we start out very much on the small end. 1/2 inch in diameter, 1/4 inch in diameter is that pea to marble size. When we start to get more concerned, when the warnings start to be issued, is for hail to the size of quarters. That would be 1 inch in diameter or larger. Typically, our hailstones in southern Wisconsin would be golf ball and smaller. Now, sometimes we can get hail larger than that, but I mean, to get it to tennis ball size, 2.5 inches in diameter, there's got to be a lot going on in the storm, which we'll talk about here. But look at this. It can be as large as grapefruits. That would be over 4 inches in diameter. And I can tell you, back when I worked in Nebraska many, many years ago, there were reports of hail up to grapefruit size. Could you imagine that? Grapefruit size ice falling from the sky. That's the type of hail that would come crashing through your roof. I mean, that's monster hail. But really, anything over golf ball size, pretty rare here in southern Wisconsin. So how does hail form, and how does some of this large hail form? Well, let's talk about this. And you can see here on the scale just how rare it is the larger those hailstones get. All right, you ready? We're going to fly into the thunderstorm here. Now, thunderstorms are made up of updrafts, which is a warm layer of air coming up into the storm. That's what's feeding into the storm, the warm, moist air. And then you have downdrafts coming out of the storm. That would be the cooler air coming out. So we're going to focus on the updraft portion of this here. That's the air rising up into the thunderstorm. And you have water droplets, of course, which are what a storm cloud or a cumulonimbus cloud is made out of, right? And so you get water naturally in a thunderstorm, and as that updraft is pushing that water up, well, what happens? When you go up, it gets colder, right? So as that updraft is pushing that water up, it's going to freeze and turn to ice. And then that ice, or that hailstone, is going to kind of bob up and down here in that updraft, and then more water is going to form on it, and it's going to get pushed back up again into the updraft of the storm, and that is going to cause the hailstone to get bigger. Now, it's interesting here because it's layered, almost like the rings of a tree. In fact, if you ever were to see a large hailstone like the ones that we showed you in the Evansville area, if you were to cut into that, you would see what looks like this, which would be like the rings of a tree, right? And the number of layers that you see here correspond to the number of times that hailstone went up and down in that updraft. But wait, how does it fall out of the cloud, first of all, and then how is hail sized determined? Well, that has to do with the wind speed in the updraft of the thunderstorm. So in other words, the stronger the winds in the storm, it's going to be able to support larger hailstones, because once the hailstone gets too heavy, the wind can no longer support it, and it falls out of the cloud. So another way to think about this is that the larger hailstones are typically with the stronger thunderstorms with the stronger updraft. So the stronger the winds inside the storm, the larger those hailstones will be before getting too heavy and then falling right out of the cloud. And here's another photo for you. This is from Lisa in Mugwanago from that same date, April the 18th of 2025, showing quarters, if not a bit larger than that, in terms of hailstones. Again, if you cut into one of these, it'll look like the rings of a tree, and you can see how many times that hailstone cycled through the storm before dropping out of the cloud.